Welcome to table for 92, element number 85, astatine. It's number 85 because it has exactly 85 protons within its nucleus. The element, so cool, it doesn't even really exist, except in our imaginations. Yeah, astatine serves no real purpose, again, because it doesn't really exist anymore. Astatine is not found in foods, it's not really found in anything, and that's because astatine is extremely radioactive. Like, we think there's only about maybe 50 milligrams that exist within the first mile of Earth's crust. It's just so radioactive that most of it has decayed away since the formation of Earth. So we're not actually cooking with astatine because, like, I can't afford it, and it's really radioactive, so it would probably kill you if I could even get it. So for astatine, we're cooking up this delicious cioppino. It's an Italian Californian seafood stew to honor the discoverer of astatine, the great Emilio Segrè, who also discovered technetium while he was still living in Italy. He actually became an American citizen because he was kind of stuck in California during World War II, and he became an American citizen soon after. The hunt for astatine, though, it's been going on, like, I mean, really since we figured out what, like, chemical elements were. And, you know, we're trying to collect them all, kind of like collecting Pokemon. Actually, like, the discovery of the elements and, like, collecting Pokemon is a pretty good analogy. It's like, you know, gotta get them all. And I guess in this circumstance, Mewtwo would be the astatine of the elements in that analogy because it's radioactive and extremely rare. That works, actually. But yeah, cioppino. So before I get into, like, the not at all absurdly short history of the elements discovered before radioactivity was figured out, we'll start the base for this cioppino because it needs time to reduce. Chop 2 yellow onions and add to a stock pot. You want to cook this with olive oil on a lower heat. You don't want to brown the onion. You want it to be nice and soft and translucent. Add, you know, a good amount of minced garlic about halfway through. There's a great documentary about people who are obsessed with garlic from 1980 called Garlic is as Good as 10 Mothers. And it's all about, like, garlic fanatics. It's a fun watch, and it's actually very famous. Like, it's in the Library of Congress. But yeah, add as much garlic as you want. Like, I love garlic, and I don't have a date tonight, so let's go for it. Garlic, baby. Add 2 15-ounce cans of tomato sauce, 2 28-ounce cans of whole canned tomatoes, 2 cups of water, 2 cups of red wine, a cup of clam juice, a few drops of red wine vinegar, some sofrito, and like 4 Calabrian hot chilies chopped up to add some spice. And then, you know, add some dried Italian herbs, fresh basil, fresh oregano, you know, whatever you have in your garden. Bring that all to a boil and let it reduce while I give you an absurdly short history of the discovery of the elements up to the time of radioactivity being figured out. We knew about some elements in ancient times, you know, like the ones that are found naturally in a pure state like copper or gold. Some other elements were discovered like zinc and bismuth by people in India and what is now Peru, respectively. But about 600 to 700 years ago, the modern idea of the scientific method and the opening of chemistry started going on, right? The discovery of elements in the 16 and 1700s is a big deal. It's often noted that phosphorus is the first element discovered in the modern era, when in 1669, Henrik Brann distilled down his own urine in a search to create gold. You know, the whole philosopher's stone thing? Yeah, urine is yellow and gold is yellow. Not a great connection, but he made it, and yeah, God, that guy was definitely dehydrated. But yeah, that was considered to be like some of the first elements to be discovered in the modern period. The discovery of hydrogen about 100 years after Henrik Brand's weird urine discovery was made. Henry Cavendish was able to demonstrate that he could create water by burning hydrogen gas, hence the name hydrogen, meaning water giver. This is when I would at least argue that we really started to figure out what chemical elements were, that they're things that can no longer be reduced down to anything else. But since most elements aren't found in a pure state of nature, they have to be extracted from the source minerals they found. So, you know, they're in the Earth's crust. They're bound to other elements in a web of chemistry, physics, and confusion. So, you know, I mean, this stuff is confusing today. Like, imagine being in the 1700s. They didn't even know about germs yet, and they're trying to find elements. Like, forget about it. So throughout the 1800s, tons of elements were being discovered, and everyone was super happy about it. But there were a couple things that had to happen for the remaining few elements to be found. So Dmitri Mendeleev gave us the periodic table in 1859, but at the time only 63 of the naturally occurring elements had been found. So it was like we had this incomplete puzzle to solve with all these missing pieces. By the time radioactivity was discovered in 1896, and it wasn't by Marie Curie, as is often thought, it was actually by Antoine-Henri Becquerel. He was a close colleague of the Curies. Physicists, though, at the time, and chemists, they really believed like all the big parts of the periodic table had been discovered, and like the elements that were left were nothing more than like mere curiosities, which is crazy because then radioactivity. So yeah, Marie Curie did coin the term radioactivity. And by the way, The literal definition of radioactivity is properly exhibited by certain types of matter emitting energy and subatomic particles spontaneously. It is, in essence, an attribute of individual atomic nuclei. An unstable nucleus will decompose simultaneously or decay into a more stable configuration, but will only do so in specific ways by emitting certain particles or certain forms of electromagnetic energy. Radioactive decay is a property of several naturally occurring elements as well as artificially produced isotopes of the elements. Thank you, Britannica. So once radioactivity was discovered, again, there was only a few of those missing pieces on the periodic table, and they turned out to be like the very radioactive elements like astatine that are basically gone from existence because of how radioactive they are. So little neck clams, check for open shells. Mussels, check for open shells. I got some East Coast blue crabs, some prawns, calamari, and some flounder fillets. So the history of cioppino is really cool. It really is like an American or Californian invention by Italian immigrants to the Bay Area. I'm from the East Coast. Like, everyone here knows the contribution of Italian people to the US in general and the food in the US in particular, especially on the East Coast. But tons of Italian fishermen emigrated to California to work in the waters of the Pacific. I mean, Joe DiMaggio's father was a fisherman in San Francisco in like the early 1900s. We don't know when cioppino was invented. It was like sometime between 1850 and 1890 when tons of Italian, mostly Genoese fishermen came to the Bay Area, and they would simply like make these fish stews with the catch of the day. Like, someone would keep a pot going at the wharf, someone would throw in a crab, someone else some veggies, someone else like mussels, and like they would chip into cioppino. That's the apocryphal story of the name. Cioppino most likely comes from the Northern Italian dialect word ciuppin, meaning fish stew. But yeah, like, there's no recipe. It's just like a tomato-based fish stew. Whatever you got on hand, throw it in with some tomatoes. So the next part of the story of astatine is eerily similar to the hunt for technetium, which was also discovered by Emilio Segrè, where you have this kind of bizarre period of time where scientists all over the world are claiming to have filled in that blank, which would, eventually be called astatine. But yeah, with so little known on how to prove the existence of number 85, you have these chemists and physicists trying out different methods to figure things out. So yeah, just like technetium, where there's a whole bunch of discoveries that didn't really pan out, and the proposed names that, never stuck. Every time there was a claim of an element that ended up being wrong. Even before officially being discovered, Mendeleev, who, created the periodic table, had named a lot of these yet to be discovered elements. And this one in particular, he named iodine, since it's one below iodine on the periodic table. So the first claim to fill in that empty gap on the periodic table was in 1931 at what is now called Auburn University in Alabama. So they put forward the name Alabamine. And yeah, thankfully, like, that discovery was later debunked by scientists from UC Berkeley. The next discovery came from what is now Bangladesh in the city of Dhaka, which offered the name Dakin, which also turned out to be discredited. So with astatine, things got so muddled with all these like fake discoveries or false discoveries that people actually started to doubt it even existed, or like, number 85 was just an anomaly. But alas, it does exist. The search for number 85 on the periodic table was mostly halted in Europe during the 1940s because of, war. Emilio Segrè, the discoverer of the also radioactive technetium, just before the war had fled fascist Italy and came to America to work, where he would eventually join the Manhattan Project. I'm still a little pissed they didn't have him in Oppenheimer, though. Like, he was Emilio Segrè. He was very important to the development of the nuclear bomb, and very interesting man, but anyway. Yeah, during the war, there was a Romanian scientist who did some good work on iodine, or, number 85. His name was Horia Hulabai, and while he isn't credited with the discovery, he was a pioneer in X-ray lines and did actually have samples of number 85. He just didn't have the technology to isolate it at the time. His laboratory was destroyed in an Allied bombing run, but what Hulabai wanted to name 85 is really telling. He wanted to name it Dor, which is the Romanian word for longing, as in longing for the war to be over. And this kind of hit me hard because it portrays this dogmatic shift away from the nationalism that had dominated science for so many generations. Like, in the late 1800s and early 1900s, scientists were naming elements that, belong to all of us after their own European countries, gallium, germanium, ruthenium. It's a way to propagandize fundamental parts of the universe to spread the glory of their countries. Countries that, over the next couple generations would kill one another on a scale not even imaginable to even the most cynical human being. And Hulabai wanted to name his element as a tearful reproach, pleading for an end to the war that had not only destroyed his laboratory, but his world. I mean, out of the small number of people who were involved in the discovery of astatine, you have to think about this, like, very small number of people, right? 2 were forced for their homes for being Jewish, and 1 had his lab blown up. He got to see firsthand the poison of nationalism that was perpetuated by scientists in a lot of ways. And he protested it the only way that he could. Plus, it would have been a funny name just to have an element named Dor. I don't know. Conflicts influenced the discovery of so many elements, and the nationalism that helped cause them it's forever enshrined on the elements that we use every day. Germanium, francium, gallium, ruthenium. So Emilio Segrè and Carlo were part of the duo that discovered technetium in 1937 in Sicily. I cooked up this really delicious pasta alla norma for that one. So Segrè was on a trip to California not long after discovering technetium to lecture at Berkeley. And at that time, he discovered that Mussolini's fascist Italy had passed racial laws similar to Nazi Germany that excluded Jewish people from university appointments. So he stayed in California, and he was able to bring his wife and children to California via Mexico. So he was essentially getting drawn into the world of good old elusive number 85. And I mean, you can't imagine, but I'm sure how anxious he was about the situation for his friends and family back in Europe. He got out, he got his family out. Not a lot of people can say that. So Segrè and friends set about figuring out how to gently nestle the ridiculously radioactive astatine out of, well, basically thin air. Because again, it doesn't really exist except in our imaginations. So the process in which Emilio Segrè and friends performed this experiment was, I mean, nothing short of magical. They took a sheet of bismuth 2 doors down from astatine on the periodic table, blasted it with alpha particles, which converted it into astatine-211, which has a half-life of 7.5 hours. Just long enough to confirm they had created an astatine isotope that could be observed. And they gave it the name astatine from the Greek astatos, meaning unstable. But it was 1940 when that happened, you know. World War II is going on. The US gets involved after 1941. So all of the most important physicists immediately started with the Manhattan Project and stopped their regular research. Many of them were Jewish refugees from Europe, like Emilio Segrè. But after the war, the research recommenced. Not like there was a lot of research. Yeah, we can create astatine isotopes, but there's less than 50 milligrams of the stuff in the first mile of Earth's crust. And all of the 30 isotopes of astatine we know about, all of them have a half-life of less than 8 hours. Plus, yeah, only astatine-214 to 219 can even be found in Earth's crust. So, I mean, again, just ridiculously rare. Of course, since there is so little of it, there are no uses for astatine yet. There's some really promising evidence of astatine-211 being used in cancer treatments. There are other treatments, such as the radioactive isotope iodine-131, that are used in thyroid cancer treatments. But iodine-131 and other therapeutic radioactive treatments have issues. They transmit beta particles. Beta particles are electrons expelled from the nucleus that move quickly and can go through a couple millimeters of tissue. That is good when you are working with large cancerous tumors. But when trying to eliminate small bunches of cancerous cells, the radiation treatment can affect the healthy tissue around it. But because actinium-211 is so radioactive, its half-life only being 7.5 hours, and it decays into a non-radioactive isotope of lead. So after 2 days, less than 1% of the original radiation is left in the treatment area. Astatine-211 is also an alpha emitter, not a beta. This is a real thing, not like those jabronis on Twitter saying that they're alpha males or whatever nonsense. So this is really exciting stuff. There are ongoing clinical trials, but right now the thing standing in the way is figuring out how to attach the radioactive and therapeutic astatine atoms to a molecule that will hunt down cancerous cells and then make sure it harmlessly decays into the non-radioactive lead isotopes in due course. The rarest, most elusive elements may quite soon be one of the most sought after. It's very exciting. Oh yeah, that is tasty. It's fantastic. It's super simple, and again, there's no real recipe to it. Any seafood, red sauce you have on hand, herbs, throw it all together. It's fantastic. And yes, I am aware this is a bunch of shellfish, and I'm honoring a Jewish man, Emilio Segrè. I don't know if he kept kosher or not, but hey, this is, you know, the classic Italian Californian dish, and it's where Astatine was discovered. So I think it's pretty appropriate. Thanks. See you next time.